Okay, hello, good morning. So it's really fun, like this Bonsify project. It's spurring up a lot of discussions, uh, really great ones for like reflection. And one thing, and also like the tests were broken for some reason. Uh, let's see. Yeah. So let's see. Let's go into because I made some. Let's see. Yeah. So what I did is give the project like so you can import the bubble plugin and the SWC plugin directly from it. And it's based on this project we created yesterday, where I think we have a pull request. Oh, it was a typo. Oh, look at that. Thank you. Approve. Let's see. Oh, where are we? Oh, back. Observing components. Yeah, so observing components allows you to use any like project that creates observation for like it doesn't even have to be for React. It can be Preact or whatever. It basically just adds a higher order function around the function that returns JSX. That's all it does. And then you can configure the name of the higher order function, like the import name, and the import path. While here in these Bonsify specific ones, they just use the other library and then it like defines those paths or those options for you. So you don't have to pass anything to these plugins. They're like configured. Anyways, so another thing that popped up, and this is very, very interesting, and this kind of goes to the heart of like it's this pendulum, right? With everything. So for me, I think I might have been like in the middle of like creating boundaries and ensuring guarantees and doing like encapsulation to like restrict how the system can work, which is I would say is kind of like Overmind world. Yeah, but Overmind has a lot of like very specific primitives and abstractions to handle that. And then my pendulum swing to being even more conservative, like embracing only React, using like only reducers and stuff like that. And it just wasn't a good experience. So now my pendulum is like swinging way back, like fuck everything. But there's something about it. What did I write here? Defaulting to blow it up a little bit. Defaulting. Oh, what happened? Defaulting to strong guarantees encapsulation typically slows down development. So when you're starting a project or you're starting a new feature, like having to like work within these constraints slows you down. Like you can't just like as I try to put it, like stream your intentions into code. Just do what you're thinking. And in the starting phase, this is really, really important to be productive and basically get into the flow of like the creation phase. And I think it's also important when people join a project. Like if people join a project and they see all these abstractions and primitives around very simple concepts of just having some state and changing it, it's like it's not a great experience. But then on the other side, there's this argument of maintainability, right? If people can just freewheel everything and every feature looks different and you can change anything from anywhere, like the thing about reactivity is that the system always stays consistent. So that's not the worry. It's more of a principle that can lead into because I've been discussing this with Damien, their open source friend. So one example of that would be maybe you have some state that you change in like 10 different places. And then you want to do something when that state changes. You want to restrict that state change. So what you have to do is like you have to create like a method to change that state, and then you want to restrict access to that state or restrict changeability to that state. And then you have to go and refactor these 3 like call sites or these 3 places where the state is changed. But if you had constraints in place in the first place, you only would have to change the existing constraint of changing that state, right? But then, and that's true, but then the discussion starts like, what did you have to pay like on every other state change that didn't need this constraint? What was the cost of implementing those with those constraints? One thing is like number of abstractions and primitives, amount of lines of code, but it's more important like how does it affect the mental model and this flow of like streaming intentions into code. It sounds very hippie, but yeah, that's how I think about it. And I try to question like, what if you do give free will? Like you can do whatever you want, but as a team, if you want to create something maintainable, you use patterns to add these guarantees, encapsulations, and creating these constraints. You don't rely on the abstractions and primitives of the framework. And the result of that is whenever you start a new feature, like I come from a startup world where things have to move very, very fast and things are old immediately when it's released. Like it's something that will definitely change in a couple of months, right? So if you develop something and you start to understand where like these constraints needs to be, like you apply those constraints, but whenever you start something new, you're back to basics. You're back in freewheel mode and you can just run with it. And then you learn and you add some more constraints if you discover any constraints that needs to be applied. As opposed to having like these abstractions and primitives and constraints in place for absolutely everything and with the cost of that. So, for example, Redux requires you to create an action, dispatch it, and then resolve an immutable state change within a reducer. This encapsulates the set and gives some guarantees, but it slows you down. With Bonsify, we rather subscribe to an open and accessible model where you, as a developer and team, create guarantees and encapsulations where it makes sense. Okay, so this is an example of how you would use such a pattern. So if you don't want, actually we can update this because I made one tiny mistake here. So this should also be a getter because you shouldn't be able to create change the ID, right? Yeah, maybe we can just commit it and yeah, okay, let's commit it. So if you have this data and you don't want that data to be changed from everywhere, you want to control how that data is changed, you don't even have to expose the data at all. What you do is that when you create like the item or the data object that's going to access and control that data, like I think I've heard this before, but I think as developers, we should learn about closures more than classes. Like closures are amazing. Like having a function that returns an object that points to internal things is amazing. It's an amazing concept and is right there in JavaScript. Anyways, so you create this item, and then the data that's like part of that item, you just make it reactive, but you keep it inside the function, like in the closure. And then you return the object that interacts with that reactive data, where you apply your constraints. So we don't want you to be able to change the ID. We don't want you to be able to change completed. We want you to call toggle to actually flip that completed back and forth, for example. And it acts like a proxy to the protected data. And then the thing is, again, you might not want to do this for everything. Maybe you just want to use this for like your actual data, or you don't want to do it at all, right? You don't care. It's such a simple thing, and the team is fully aligned and everything, we're just running with it. And that's perfectly fine, whatever works. But now you can lean on this pattern to create those constraints. Yeah, so again, as I'm saying, like my pendulum is is swinging strongly towards the other side. But the perspective is more important, because the perspective is, how do we create value with as little friction and as fast as possible? Like, that's a good perspective. As opposed to, how do we make, like, it's a messy perspective, but like building products and figuring out what's the right thing for a user, that is a messy process. The user doesn't get value because you have amazing constraints in your state management. That's not what creates amazing experience. Yes, maybe it reduces bugs, like, but again, like, you will always have bugs. And the thing is not like minimizing the amount of bugs by adding a bunch of abstractions and primitives. It's being exceptionally responsive to feedback and dog fooding your own product. Like, there's so many other principles that's more part of product development than engineering that creates great value and a good experience for users. Like, it's such a, like, the conservative swing of the pendulum is such a technical focused, how does the code execute kind of perspective, while on the other side is more of a product perspective and like developer experience perspective, where, okay, we're gonna have so much fun creating this experience for our users. We're gonna be super in tune, have a great feedback loop. Whenever we get feedback on changes, it's out in the next hour kind of thing. That's where you want to be, at least as a startup. Like, I haven't worked in like huge ass enterprise, but also in enterprise, like, people complain about how much time things take, and they're so unresponsive to feedback and all of this. And I've seen, like, even like government services change. Like, they go into more of a startup mentality where they build new products internally with smaller teams, and they choose their own tools and everything with great success. But again, like, this is a gray area. But yeah, reflections. Okay. So what I also wanted to explore, let's see if this thing is actually running. Demo. Oh. So this demo is now running with the new observer project. Let's see. Oh shit. Oh, maybe I didn't. Oh, yeah, sorry, I linked it. I have to build it first. Oh, for fuck's sake. Oh, yarn install. Sorry, I was working on my laptop. Then we build it. And then we started. There we go. Yeah, so this is still running. Okay, so let's talk about testing first. So I haven't like explicitly written about that in documentation, but it's really part of, well, actually we kind of have testing here. Yeah, okay. So we kind of already have it in this example. So, yeah, interesting. Should we, doesn't matter. Okay, so what I've done here is I created this counter app. Again, like it's silly simple, but you can imagine this being like your whole app. But the point of making it a factory like this is because you can pass in dependencies, right? You could say that a dependency, like an environment dependency would be like some configuration of like whatever, like a URL or some kind of flag or whatever that defines how the app should work in that environment. But it also means, like I'm trying to find a good word that everyone can relate to. I call it side effects, but side effects is more like, that can also be like a side effect of a code change. And we call it effects in Overmind. It's basically what you want your state tree and the logic you put into your state tree to look like is domain specific. It should always like reference your domain. It shouldn't call functions and use lower level APIs from the browser or whatever in that area of the code. So the way you, and that just makes your code more readable and more precise. And it increases testability. So for example, what if adding two numbers together was like a browser API, right? It was maybe asynchronous or whatever. Instead of like using this.count equals browser, this is silly, add two numbers, like you wouldn't do that because this is not domain specific. What you would, and also these like third party, and that's also what I mean, third party APIs. You wouldn't want Firebase in here because Firebase has nothing to do with your app. Your app wants to persist, right? So it doesn't care about what persistence you have. It just wants to persist. So that's also maybe a much better example. And the way you solve that is that you just build these abstractions outside of your app. So for example, in this case, I have this utils file, and this is where I would create all these interfaces that that is not specific. So I think Firebase is like persistence is a really good example. So instead of like having functions that reference Firebase and specific functionality of Firebase, you rather have like persistence. That's the common ground between your app and Firebase. It's like persistence. So you would have functions that relate to persistence. And that also means like there's this argument, and then you can rip out Firebase later and replace it with something else. I don't care about that. That is very unlikely that you're going to do that. You'll probably move to a new employer or start a new startup before you ever do that. But the point is to make your actual application code as specific as possible, and not litter it with terminology from other things. So again, you can imagine like you would have, we're gonna run with this Firebase thing. So what you might have done here is, I will put this in its own file, but you would do create Firebase util, for example. And then here you would like maybe you would have the config for Firebase, and then you would say app, okay, initialize app config, and then you would return a specific API or create Firebase persistence. I'm just trying to choose words there that makes sense because it's like educational. Persistence. But you would return like save to do, something like that. And then you will pass it to do and the to do. And the point is that you do not only want to make things avoid like third-party terminology, like Firebase in this case. You also want things to be typed. So if you use like third-party and browser APIs directly, you have to add the typing inline. Just even using the fetch API of the browser, you have to explicitly set the type of the returned result. But here, when you have this like interface, you define the typing here. So when you consume the persistence in this case in your actual application logic, you don't have to define the types. You're just getting help from TypeScript all the time. Like whenever you save something, you know what to pass. Whenever you fetch something, you know what you get, so on and so on. And then you can even like in utils, you make that a factory, right? Because you want persistence to be create Firebase persistence. And then from the utils, you get the actual like options or whatever. And then you do options Firebase config, something like that. And the options could even be like options dot local persistence, and then you would do create mem persistence. Like you can do, that's the whole point. Like you just use these functions to configure the environment. So you might use mem persistence for testing, for example, or development or whatever, because your app isn't these third-party libraries. It's this interface that you're creating. So let's remove that. So what you would do then is in the yeah, sorry. So now I made this a function. So this will be return type of utils. So in the app, we would rather call utils here, right? And then what you would then do, maybe it's obvious now, because what you would then do for testing is just create a counter, right? But you can pass different utils. So imagine we're in a testing, yeah, maybe we can do this. Test adds up the numbers. So I will create like test app, create counter. And now I can just go in and I can mock this adder, right? You can do whatever you want. And then you do test app, increase, and then you check the result. Like this was kind of a bad example because the adder is so silly and you're kind of just re-implementing the thing. But you get my drift. And then you can also like make it partial, so you don't have to like mock everything. You can also like, you can call utils with a specific config that makes it like locally runnable. Like I mentioned, it doesn't create Firebase connection. It uses in memory. And that's how you do it. Like whatever you want to call it. The point is, there's no specific way of doing this. It's all about patterns. But using functions and closures is the thing that gets you wherever you want to go. Wow, I'm full of good statements today, I feel like. Cool. So that's the other thing I want to talk about. And then the last thing I wanted to talk about is promises, and this is actually more of an exploration, because I got a question about, like, what if I have a list of items and each item in that list has a type, and based on the type I want to fetch additional data. And one thing I'm wondering, no, I actually threw away that idea. But what we're gonna try is to see if we can make a promise reactive by simply doing or maybe we can even make the count promise dot resolve. How should we do this? Need a good example. Count isn't good because I want the result of the promise to be reactive, and the number 0 can't be reactive. Maybe I can just make the whole thing. Okay, so let's just change this a little bit. So we're gonna export. Yeah, and another thing related to testing is that you can test each namespace. So if you have like create counter, you can just call create counter and test that in isolation. And if you're doing React components, you can and you expose the root state of your application state on the context, you can now do the same in the test. So you create a fake, not a fake, but a mocked create counter, and you expose that on the context to the UI that actually uses that counter. So it doesn't have anything else from your app. It just has that thing. So that's also really nice. But let's do app, and this is a reactive thing. So we're gonna do this, this, and then we're gonna have our counter is gonna be create counter. Yeah, let's bring up, and yeah, and this shows you how. Oh yeah, sorry. Oh, did I call it? Oh no, whatever. So this also shows you how you like you have something called dependency injection, which is used by can be used in classes. It's kind of it's a nice feature because it's kind of like funny enough, it's like instead of doing props passing that we're kind of doing here, you almost, well, you can compare it, but the point is you kind of just, it's like using context. In React, instead of props passing, you use the context. Use context is kind of dependency injection. But you can't do that here because that would require a special abstraction and probably some primitives, and you would have to like bend your or understand the concept. There's another mental model, but here it's just passing an argument to a function. But the thing is, in components, you might have like many nested levels, right? That's the whole point of context. It's to avoid having to pass props so many levels. But in an application state tree, you don't have that many levels. So passing those dependencies down to these namespaces or whatever, that's not such a big deal. Anyways, so now we have this thing, and we're gonna make this whole thing. Let's see. Yeah, so we're gonna return a promise of this reactive state. Oh, sorry. Okay, so now this is a promise of a counter. And yeah, let's just try this first. And then we're gonna talk about something related. So let's create app. Oh, didn't I export it? Oh, sorry. Create app. So we have create app. And then what we're gonna do is, let's see, export default function app wrapper. We're actually gonna use suspense here. This suspense isn't actually gonna trigger, but we're gonna play a little bit more with this. Because what we're gonna do is say counter use app.counter. Counter. Let's just put the number here. Counter.count. I'm just wondering if there's something I haven't thought about. Like this should just work. Oh, isn't there text here? Wait a minute. 5173. Oh, this is. Oh, wait a minute. This is not a promise. Oh, that's X. Hey, why does it say that? Oh. Oh, yeah, hi, Desm. Sorry, I was like way into it. Yeah, so let me answer the question. Can you quickly describe the diff between this and impact or even Overmind? Yeah, so Overmind was like Cerebral was, for me personally, on the projects I worked on, a big success. Like people gave a lot of feedback that it helped them to manage complexity in their apps. And I was even part of a startup that made it because of like building that tool, as there were junior developers, we're a tiny team, there was a lot we had to do, and it was a big success for us. And then Overmind had the exact same concept, but it was driven out of the release of TypeScript, because Cerebral doesn't support TypeScript because it has such an exotic API. So Overmind was like, okay, let's drop the exotic API of sequences and operators and all of this stuff and just use plain functions. But it's the same thing. It's just your app is, instead of like state and sequences, it's state and actions. And then proxies had arrived. So instead of like manually mapping like these changes in Cerebral to things and observation, trigger observation, all of this stuff, you could just dot into your state, and we use proxies to observe and handle mutations and everything. So it was just a natural successor, yeah, to Cerebral. Now, Impact is like based on a completely different thing, because at Code Sandbox, Code Sandbox originally ran on Redux, and the reason I actually started at Code Sandbox, was because I refactored the client to Cerebral, because there were performance issues. And Yves, one of the founders of Code Sandbox, he's like a proper founder. He likes to move really, really fast. So it also helped him move much faster with the project. And then we wanted to introduce TypeScript, so we did that. And with Overmind, I was able to refactor it again. And we were like super, super productive and happy about using that tool. But then as we were building the new Code Sandbox client, there was one little trigger, and that was strict null checking. Because we had a lot of ifs in our code base that checked if something was in the state. Like from the perspective of the action or the component, as developers, we knew that the user, for example, was always there. But the way we have typed it in the state tree is that the user can be there or might not be there. So isolated in the action or the component, it was like it didn't know the context it was in. It didn't know about its parent components or its parent state, or that the state had actually resolved the user. Like the action couldn't be called without the user. The component couldn't be rendered without the user. But the component and the action didn't know that. And that bugged the hell out of me. Like, why is our code like this? And since Overmind isn't able to doesn't put actions and state together, like you can always access all state, you can always access all actions. It's not bound together. We weren't able to type that correctly, and that led me down a dark path of embracing React, using like reducers and state machines. Like, not that state machines are bad, but using like explicit states to kind of dictate that, okay, in this state, we have the user, for example. And then we would use that so we didn't have problems with strict null checking. Like, we couldn't literally turn on strict null checking in the old code base of Code Sandbox because it gave like thousands of errors, or at least hundreds. But let's see. Where was I? Yeah, so this embracing of React and using reducers for like explicit states, I learned a lot from it. And what I learned is that it was, it created a lot of indirection, meaning that we had state inside our reducers, but we had like the actions or what's dispatching outside of the reducers. And then, so you had like logic in two different files, so it was very hard to reason about. And then we were reacting to state changes. So when it did a state change, then we triggered some effect based on that, instead of like calling an action, run the effects, change the state in one and same thing, like you do with an action in Overmind. So that was a big lesson. So Impact then came out of this idea of, okay, let's get back to the simplicity of just, like, we want to keep immutability. We want to keep immutability, but we want to move back to observation, not using like React reducers, but go back to observation. Signals was a big thing. Like, okay, signals has immutability in them, but they also have observation. So this is a really nice primitive. But then how do we handle like this narrowing of state? So you know in any context what state is actually available there and what functionality is available to you in that state. And that's what Impact tried to solve. But Impact has like, it's not released yet, and I'm fairly confident it won't be released. Because we never got a chance to dogfood it, and I don't want to release something I haven't been using myself. But yeah, so Impact has like this principle of, or trying to resolve the original problem of strict null checking. And it does that by allowing you to nest your stores. So you can have a root store, and then in a nested store, in a component somewhere, you instantiate that store by, for example, passing in the user. So there's a store that only works when there is an actual user. So the root store, you have some components, the components resolves a user, and then the component starts up a new store that's embracing a bunch of other components. And all those components can now be guaranteed that there's a user there, because that store wouldn't be there if there wasn't a user there. And then, yeah, now back up to this project. This is about like what the fudge? Like, objects are awesome. Like in an object, like why are we separating state from functions? Like why are we having all these primitives and abstractions to try to resolve these problems? And what if we just have a JavaScript object and a function? Like, can we solve everything we try to solve by just having objects and functions? And the only thing the library needs to do is to make that object reactive, because that's not something you can express in just JavaScript. And where does it take us? And that's what we're exploring here. Because this is a Bonsify thing, it's just one primitive, which is called reactive. And then we're exploring patterns to solve, like, and discussing. Like, this started out as more of a educational discussion project, and it's much more fun to discuss and talk about things when you can actually write code and see things working in practice. But yeah, that was a exceptionally long-winded answer. But yeah, that's the reason. But we have a problem. So this use hook, okay, but I think we can fix it. I'm gonna ask ChatGPT. So I am creating a proxy in TypeScript around state as a state tree. When I put a promise in that state tree, I want the instance to identify it. I want to. Oh, wait a minute. I actually think this is quite simple. It's just that we're not identifying. Let's see. Because we have this is object. Is accessing. Is accessing. Let's see. I think we can update this. Oh, sorry, this is array proxy. This is where I was going. So I think it's accessing. Yeah. So if type of key is symbol, or type of result is function, or result and instance of result. That's weird. Oh, can I say type of promise? Is that a thing? No, that's object. Yeah. And if it's an wait a minute, and result instant. Oh, interesting. Okay, we can move this into like a better test, but yeah, why does it ask any? Doesn't matter. So yeah, let's try this. The problem is that I put a proxy around the promise, so React wasn't able to. Yeah, thanks. I'm just super pumped about this project. I don't. It's just fun with all the like. One thing I missed a lot is the engagement with like community and open source, because I've been having these small kids and haven't had the energy or focus to be able to do that. And then, but I've still had like this like strong motivation for like reflections and building things and learning things. but it has been more of a closed loop. So it's super awesome to be back and engaging again. And it's also awesome to like create something that actually creates some engagement. But yeah, let's build this, and then I think we can just refresh. Yeah, now it's loading. Yeah, so you see that? Wait a minute. We're going to do one more thing. We're going to make sure that we're not looking at anything else. We're not going to add the item. We're just going to increase the count. Yeah, so you see that? So putting a promise, and we're suspending it, right? So just to reiterate, this, like I'm going to change the example, but what we did is we added a promise to our state tree, and we made a value reactive. And then you can just use that value with the use hook, and React handles it for you. But what's even more interesting is that we can, instead of making the counter a promise, we can make add item. We can make every item have a promise, because that was the original question from Adam, also their open source friend. How would you handle having a list of where each item needs to fetch some data based on its type? We're not going to bring in the type here, but we're going to fetch some data. We're going to fetch some data. So let's just call it data. And we're going to fetch data. Let's, how should we do this? Let's just do a new promise, resolve, and then we're going to have a random time. Oh, set timeout, math.random times 1,000, something like that, or 10,000. Is that a lot? 1,000. How much is that? So that's like, it will be 1,000. Yeah, so it will be 1 second, or it will be less than 1 second. Let's do like 3. So we're gonna resolve. Yeah, let's just resolve data. That's fine. But what we're doing now, okay, so what we're gonna do is fetch data, then reactive. That's what we're gonna do. Yeah, this is gonna be interesting. Okay, wait a minute. What we're gonna do, we're gonna put a counter in cell. Fetch counter. This is gonna seem a little bit silly. Or create counter. Let's say it takes like a random amount of time to create a counter. So let's do new promise. And this is just gonna create that counter. Yeah, sorry, it's type unknown. So let's this is gonna be count number increased. Why is this oh, this is interesting. Why is it saying that? That was interesting. Yeah, like this is very pseudocode. You would never do anything like that. Oh, sorry. By the way, we shouldn't have I'm not supposed to have the increase here. So the data is the count. Let's see, count 0, sorry. It's gonna make sense. I just have to get through it. So let's resolve this like create, it's really create count. And then what we're gonna do, we're not gonna have a count here. What we're gonna do is whenever we increase, we are gonna await this dot, it's gonna be an async increase. We're gonna await counter, let's call this counter. This is not gonna be, and then we're gonna have a promise. You have to excuse me. So counter would be a promise of count number, sorry. So now we're gonna say counter.count plus plus. Okay, so let's just go through it. We are building, we don't need to pass utils here. Counter. So what we are doing, we shouldn't, you know what we're gonna do? Just to make it perfectly clear. Like this is not really, this is more of a util. Like this is like fetching some function create counter, or like fetch counter, or fetch count, I guess. Whatever, fetch counter. And then we're gonna return that. Okay, and then we're gonna use the utils to fetch the counter, fetch counter. Okay, so we have this like external thing. We're fetching some data somewhere. Exactly how that's fetched, we don't care, right? We don't care if it's Firebase, the fetch API, if it's a fake promise, like doesn't matter to us. We want to fetch a counter. And when we get that result, we want to make it reactive. So that's what we're expressing here. And then we have an increase, and this increase is going to await the counter before you can increase it. So what we're going to do now is not have this. We are going to create a suspense boundary around every item. And we're not gonna do that. We're just gonna add the item. And then the item here is gonna be counter promise of count. And then we're gonna say counter is use item counter, and then counter count. Right? And we have, what's wrong about this item? Oh, number. You'll have to excuse like the pseudocode, but the whole point here is that we're doing something very quite complex. Like we're every time we add an item, yeah, you know what we're also gonna do? We're gonna move the suspense. We're gonna say item counter. So we want to show the item. Let's see. So the counter here would be counter the promise of, yeah, of count number. Well, let's just take the item. Oh my God. I should have made this a type immediately. Let's just do this item. Let's just pass in the item here as well, item. And the good thing is that we can do this now because this item doesn't change its reference. So it doesn't matter like how much we pass in. It's the only reason it will re-render is because of what we access from that object. Oh, okay, so we have item counter. So we're gonna mount that item counter by passing in the item. Cool. And then we're going to allow you to actually start increasing it, but it's going to await. Like, this is very complex asynchronous stuff. So we're gonna allow you to increase, but when you click increase, it still waits for the promise to resolve, right? And then it will increase it. So we should be able to click it, and when it resolves, it runs through this and actually updates it. And then I want to show you another thing. Okay, I think this is what we wanted to do. Oh, what happened there? Did I have another suspense? Oh, I forgot to put suspense around it, sorry. Fallback loading, sorry. So you see that? It's like loading in different orders. And if I go in, it's a little bit fast. I click it. You see that? It's got, oh, it looks weird. Let's do item like that. Yeah, let's just use a span or something. I don't know, whatever. You kind of see it. So I'm opening it, I'm clicking it. Okay, that's kind of cool, right? But another cool thing is that we can go in here and we can render item counter and render item, render app. By the way, I can make this a lot bigger. Oh, well. So we have strict mode on here, so that's gonna affect it, but yeah, maybe I should turn off strict mode just to make my point clearer. So it renders the app. It renders the app again because we added to the list, and then renders the item. It renders the item counter, and then it rendered the item counter first. How's this? So it rendered it first, and then it threw to suspense, and then it resolved the promise. So I wouldn't expect this to be 2. I would expect it to be 1, but I think this is an artifact of suspense. Or not artifact, but the point is, when I now click this, you see I'm clicking the actual item, but it's just rendering the item counter, right? And this just works. You don't have to think about all of this stuff. It just expects like you would imagine. And then when I add to the list again, you see it only rendered 1 item and 1 item counter again, which was the new one. It didn't render the other one again, right? Exactly as you would expect. So this is also part of this thing, is like, as mentioned in, like, to point that out, oh, what was this? No. This is also part of the whole thing. Is like, by default, React state management is based on props passing. In short, when using React, you will have a lot of components with a lot of props. And because of React relying on the mutable state, those props will very often change. That means you do not want to wrap every component in memo, because you will more often than not compare props. That typically changes. Just adding overhead. This is a little bit weird, because you will more often than not compare props. That typically changes. Yeah, I should change that sentence. But it means like, when you do props comparison, it's much more likely that they changed, because it's an immutable system. But when you build a reactive application where you have root state that is mutable, like with MobX or Bonsify, there is much less props passing, and the props passed are often mutable objects that will never change, but is rather observed in the nested component. In this world, it makes a lot of sense to make all components observers of reactive state and mode for optimal performance. The great thing about this is how the mental model of rendering changes. Components will only render when the state they actually access changes. There will be no waterfall reconciliation, as we saw, and you optimize your rendering by simply splitting up your components. So yeah, this was fun. We got through everything I wanted to talk about. So I'm gonna publish a new version of Bonsify that has that promise check. I'm also gonna add promises to the documentation as part of patterns, of basically just adding then reactive. That's all you need to do. And then you can use it with suspense and everything, which is really cool. Which is really, really cool. Yeah. I love talking about this stuff. But I would love to like actually be able to dog food this in some project. Like we could refactor the family app. That's kind of been my go-to, because it's a complex project. Maybe we should do that. Unless any like new discussion pops up, we can go ahead and try to refactor the family app, because it's a complex application. And that's a good enough, like if we can get through that refactor, that's a good enough dog fooding project to feel like confident about at least think about doing something more with this. But yeah, cool. Thanks for following along, and we'll talk soon.